Hello, YouTube. Alright, so the last time I left off, it was kind of fuzzy. It was the first video, and I know this video is also not very good, but I'm doing this just because someone in the comments in my last, or the one before, asked for the code. So, I have the Tricopter finished. Now, the problem is I won't be able to physically show it to you because the receiver is currently being reused for a different project because that project was urgent and it's a school project, and so mine is kind of on halt, and one of my motors are broken, so that I kind of stopped and said, okay, I won't work on it till I get my receiver back and the controller. And so that's why I haven't been doing anything much lately. Nothing. Okay, so let's launch the Arduino Ide, and the setup should be the same as last time in terms of I'm not sure if I have described. Anyways, I'll just make a thing, and if I did describe it, then I'll just decide to take this out of the video. It probably won't happen because I don't think I described how it's going to go. So, file, no. Okay, now let me make a better brush. Let's go 10. So, we have the center of our thingy here, and then we have 3 arms, right? What do you like at my drawing? Sexy, huh? Yeah, shasha. Okay, so that's the 3 you have. The propellers here, and propellers here. Now, I have a speed controller here, and I also have a speed controller here, and a speed controller here, an ESC. So, and if you don't know what an ESC is, you should probably go back and watch my first video, even though it's like long, but still, everything there is really important. Alright, so what I do is I have the Arduino send a pulse width modulated signal to the ESC, and then the ESC converts that into what's it called, alternating current, which powers the brushless motors. Now, on here I have all the pins from the receiver connected to a board, which is the Arduino Mega. The reason I'm using the Mega is because I also want to have extra sensors, and I'm going to need more pins, so I decided to use the Mega. Now, I could probably tell you more if I open my... No, wait. Yeah? Open? Yeah. Okay, so, now, I have 3 different kind of servo variables, and the reason I have them as servos is because the ESCs act practically like servos. You send them a signal between 1100 to 2000 or 2000. Now, the reason I use shorts because I feel like being efficient and not wasting as many, I don't know, spaces or bits on my thingy. So I have roll pin, which is for the roll, pitch, and thrust. Now, I have not added the yaw yet to the code, but I plan to. Now, what I do is I practically just get the attach all of these the servo pins to the different speed controllers using those 3 things. And if you notice, there should have been... Huh. Never mind. Okay. Oh yeah, that's the thing. Alright, so now the first thing I do under loop is I open my serial monitor, and that is because and what I basically do here is write to the all 3 motors the same value, and that's because you have to what's it called? What's the thing called? You have to arm your motors. In order to do that, you have to first set what type of battery you have. So I do 2000, which is the maximum, the highest value, and then that turns all the motors on and says, all right, well, what do you want to choose now? So it gives doot, and then I press 700, which gives you lithium batteries. So then it goes doot, and after that the motors should be off. Depends on what type of motors or speed controls you have. They might be on, but they should be off, and you can just then send the values from like 0 to 2000. See what happens. The values that should affect it should be between 1000 and 2000. Anything under 1000 should not turn your motors. And so you can do that. If I wanted to stop doing this and actually use my controller, what I do is I just pass in -100, and this is all through the serial communication port, which I can't show you because I don't have an Arduino plugged in. So now I pass in -100. Now the value is equal to -100, but value is going to always be -100 unless I set it to something else, because it is a field which is declared somewhere up here. Should be declared there it is. Yeah. Now, as soon as I send in -100, it'll then start running this code. Now, first thing it'll do is it'll say, okay, my field roll is equal to the pulse in of the pin that has roll, and as you can see, roll pin is pin number 3. The reason it's pin 3, 5, and 6 is because 3 is those are all pins that are pulse width modulated, so you have to be pulse width modulated pins. So I basically get the pulse width modulated signal from those using the command pulse in, and this basically says you get the the width of the high, not the width of the low. So you get the intervals of highness, not lowness. So you get the intervals of it having charge, not charge. This works the other way around, but you'll get different numbers, and so I'll have to it'll just be inverted. So instead of, if let's say this roll for high would be, if it was 500, for low it would be 150. So that kind of thing. Now, if you don't know how pulse width modulated signals work, it's fairly simple. You literally get high signal, 0 signal, 0 signal, high signal, and so this is the width of the pulse. So it's the distance between how high and low you are, and so you can change that distance to see what your signal actually is. Now, you should only be getting highs. You should only be getting the highs. So it'll turn the high on for a certain amount of time, and it'll turn it on low for a certain amount of time. I'd recommend using the high. It makes everything much nicer. So because then you would have to, if you use the lows, it wouldn't be to 2000, which is the max. It'd be to like 1900 or something. I'm not sure. So you get that, and then I call a method called skew numbers. The reason I do that is because although I get a signal from 0 to 2000, actually no, I get a signal from 1150 to 2000. That is not really going to tell me how to work with the motor. So what I do is I turn all of those numbers from, let's see, okay. I turn all those numbers from I'm not sure exactly what variable, but I think it was 100. So I skew those and I make them out of 100, 0 out of 100. And after I skew all the numbers to make the roll for the stick that turns right and left from 0 to 100, and the pitch from the stick goes forward and backwards is 0 to 100, and then the thrust is also from 0 to 100, if I'm not mistaken. So, or from 0 to like 1 or something. It's some number that like is nice. Anyways, so now after I do that, after all my numbers are skewed, what I do is I say, okay, if thrust is under 0, then multiply by -1. Yeah, and the reason I do that is because when I skewed the numbers, they're not always perfect, so you kind of want it to be at least 0. You don't want it under 0, else the motors will spaz out. Now, here what I do is I say, okay, so if my pitch is greater than 0, so if I move my stick to the right, then I basically make my first 2 motors silent. And so as you can see from this diagram right here, those are the first 2 motors. No, wait, this is pitch, right? Was that pitch? Let's turn this off. Pitch, never mind. So, if pitch, that means my stick is all the way, if pitch is greater than 0, that means my stick is all the way forward, which means I want to go forward. So, those two motors are going to have 0 value, and this is going to have 100 value. So that'll just turn this bottom side up. And I kind of do the same pattern with all of them. For the right and left, I did some trigonometry, or geometry, or whatever you want to call it, and figured out that it should be 80%. The reason it's not 50, which is a logical solution, is 50 gives you a perfect kind of flat, kind of 40-degree angle, 45-degree angle, which I don't want. So 80, that's the right number. So you use 80 for, so let's see, the first motor and the third motor, first motor is total, third motor is 80, and the second motor is 0. So if I want to move right, then my first motor, which is this, is at total, as fast as it can go, so that's going to move me this way. No, I should probably not use this. That's going to move me this way. And then the second motor is just not going to do anything. Then the third motor is going to go that way. So I go a little bit up. And what that does is that gives you a kind of right trajectory. Now, and I think this is a 30, yeah, this is triangle, is a 30, 60, 90 triangle, if you're curious. It's kind of fascinating. But anyways, the things you learn in math actually end up helping you. If you do, you should probably listen to math class. But anyways, so you do that for all of them. And then what I do is, so I basically say the value of my first motor is equal to the value of my first motor in the y direction, because I calculate my movement in the y and x direction separately, since those are two different sticks. So I basically average out the x and y direction and add that to thrust. And I do that to all of them. That gives me, what I do is I just print those values. I do this thing so that, I can see which motor is what and kind of diagnose it without even trying the tricopter itself, without having to go out, put it on the ground, tie it to a 20-pound book or something. And after I do that, now this is after I process movement. As you can see here, it says skew numbers and process movement, and it sends the values I changed from skew numbers. So after I do that, what I do is I do m1.write microseconds, and I put motor 1 plus 850. The reason I do 850 is because my values, I believe, if it's 850, then my values are from 0 to, let's see, 1,000, 1,000, 100, 1,250. My values are from 0 to 1,250, and so I add 850, so it gets a total to 2,000, because anything under 850 is not going to turn. So there's that. After that, the motor just turns. So it's fairly simple, nothing too complicated. That's what I currently have for hard-coded movement that's just manual. I have the gyroscope. I'm currently trying to figure out how to use a gyroscope on this. I will explain this better in a further video. Sorry for the terrible uploads, but finals, exams, AP classes, testing, it's hassle. So anyways, that's basically the explanation of my code. And as you can see here, I'm connected to 6 pins. The 3 inputs for the from the controller itself, and then the 3 outputs for the speed controllers. And it's fairly simple, so it shouldn't be too much for you guys. Thank you for watching, and the next time I put this video, I should have a actual video camera, and I'll be showing what the tricopter itself looks like, how the wiring is done, why I did the wiring the way I did it, how I put the motors, and some of my terrible mistakes that I've done that you should probably not do because you don't want to buy new parts. So, hope you liked the video. See you next time, and good luck.